So we're Crooble, I'm Marina, and I'm Industrial Design in NCAD, and this is Killian, and he does Chemistry in TCD. So local sustainability. The best way to try to boost local sustainability is to start in your home. With heating costs soaring and non-renewable energy sources rapidly depleting and causing more damage to the atmosphere, we need a viable energy source for the future that can be low cost, efficient, and environmentally friendly. What we created is a furnace cell product that will create, maintain, a constant temperature fueled by algae briquettes. So there's been a massive rise in fuel costs in the last few years, and none of these even unit prices even include things like standing charge or maintenance. For instance, there's been a massive increase in coal and peat with up to 10 and 12%. And Ireland's dependency on fossil fuels is atrocious. We're the fourth highest dependency of electricity generation from fossil fuels at 72%, the fourth highest in gas dependence in electricity and generation as well in Europe. And our huge dependency needs to change. We need to bring more alternative sources into the equation. And with fuel cuts coming, and in the last few years it's getting even worse. There's been cases in 2011 where the fuel allowances was cut from 32 weeks to 22 weeks. And fuel cuts can have undesirable effects. People can't afford to heat their homes, and illnesses and mortality, especially in the elderly, can happen. Those depending on the fuel allowance, there's loads, and it kind of every year more and more people are depending on it. This year alone, 211 million will be spent on fuel allowance, So what we need to solve, there's a serious need to decrease Ireland's dependence on fossil fuels. Fuel costs are rising and fuel allowances are getting tighter. People are suffering from not sufficiently generating heat in their homes because of these issues. Not only could a future product assist these problems, but it could also save the government on fuel allowances. In creating a product and a system to create sustainable heating, we are helping to protect the environment as well.
So it's really bright up here, and it's very hard to see what's actually on these screens. So basically, in Ireland, up here you can see our energy flow. So you can see a huge amount there is oil. That basically is going into our transport, but of the natural gas, that's producing our electricity. Coal and peat. Basically, less than about 6% of our energy is generated with renewable energy. We've had an increase over the past 22 years in efficiency of 35%. Globally, it seems pretty similar. And one of the problems with this is essentially what's happened is we've shifted from using coal and peat to using natural gas. So our Carnot efficiency, Carnot, thank God that was the next slide. So our Carnot cycle is limited. It limits how much energy that we can convert from our chemical thermal energy into our electrical energy. And with coal and peat, that's only 30%. And we get that up to about 40-45% with natural gas. So that's, it's not Kyoto is promoting our reduction in carbon emissions. It's really it's cheaper, it's better for the economies. So how are we going to tackle that? Well, essentially, we use a huge amount of our energy, 34%, of our energy use in Ireland is to heat our homes, specifically in thermal applications. After this, I read as well that a further 15% of absolute energy that we use goes into heating and cooling our homes as well. So nearly 50% of the energy we use in Ireland is used to heat our homes, heat our office space. And we're doing it really badly. We're using fossil fuels that emit a huge amount of carbon. Is there an alternative to this? So basically, we think that there is. So algae is a viable alternative. So if you see on the screen in blue, it has spruce wood, which is essentially a low density wood. So this would have a heating value of maybe about half, a hardwood that would take about 80 years to grow, like an oak or something like that. Where spruce wood can be grown much faster, about 20 years or so. But you can't grow anything else in that space. So one of the reasons this hasn't been developed is that it competes with farming. That's the word I was looking for. Basically, it competes with farming. And after, I don't know if you know, there was this lovely willow that was growing around Ireland. You know, it was fantastic. It was going to solve all our energy problems. And then they realized that it was really bad and had to give another grant to extract it all. So basically, we don't want to compete with farming. We want to use areas like deserts, for example. We can pump seawater in there and we can grow algae. And this creates a whole opportunity all around the world for viable alternatives. Sorry. And you can see there that with one of the algae, it actually has a higher energy value than the spruce wood. So that's just to really, if I forgot to mention it, that the renewables is really just a tiny section of what we actually use. But what's interesting is the government's perception of this. As you can see there, of the energy that we produce in Ireland, 58% is renewable. That means that we're importing a huge amount. We're totally dependent on external energy markets. And you know, maybe we don't consider this a problem, but certainly when you consider Germany and Russia and the dynamic that's going on in Ukraine, having that energy independence is vital to long-term economic viability. So that's really something that we need to work on.
And so just a bit on our name development. The product that we're creating at the moment is the furnace for the algae briquettes to be burning in. And I was kind of playing around at the beginning with a few different names, kind of turning things into Swedish to make things sound a bit more designy. But then I kind of looked at Crucible, a clay item where you heat things in, and I thought, oh, this is basically what we're doing. So I kind of played around with the word, and then eventually came up with Crooble. So this is our furnace, or kind of our stove, and it takes inspiration from the studio DIY heating kind of flower pot system. There's in some studios they'd be heating their studios at a low cost by kind of tiering 2 flower pots and having tea lights in them. And I kind of took this inspiration in the design of it, but also in the actual, the design on the exterior and the interior. There's 2 walls on the inside, and the inner compartment acts like a core, so it retains the heat longer. And then there'll be vents in the drawer that you pull out that the ashes fall into, which will control the oxygen intake. And then the drawer and the doors will slide out flush against the surface of the stove. And this is just the side view and workings of it. Basically, you put your fuel into the middle compartment, and when it's burning, your normal ash will drop, but then as your smoke rises, it will hit there's going to be a heat conducting metal sheet at just the tip where the pipe is, and this will it's
going to increase the heat extracted from the air.
And so then, in this, the soot won't be able to rise as much, and it will fall. And then we have a slide kind of incorporated into the design where the soot will actually fall into where the ashes are. So you can take the 2 out at the same time. And then.
Right. So obviously the stove is something you put into your home. We want to work. A lot of our concern is fuel poverty. Earlier on we were mentioning who this affects. So in our marketing plan, we want to work with the likes of Focus Ireland. We want to work with the Jesuit Refugee Service or some other organisation, Migrant Rights Council, Immigration Rights Council. These organisations are proposing, housing first. They're proposing, first-time homes, direct provision, and so forth. We can partner with them in putting these stoves in and change this in a very fundamental way. And then there's a market of about 800,000 people who spend the significant majority of their disposable income on heating. And we think this is another market that we can move into via them. But it's specifically what's up on the screen is our long-term plan, how we can go industrial with this. So the first stage is that we can actually work with co-location. So working with existing power stations, we can use a lot of, I was mentioning earlier that, anything from 70% down to 50% of energy is wasted. Oh, geez, you got to speed up. But we can use that to increase the efficiency of the of how we produce energy. The second thing is that the actual algae itself, if we can come up with an efficient way of producing that algae, what we can do is we can use existing schemes of anaerobic digestion to produce natural gas. And all of a sudden we have, natural gas that's actually natural. And we've got a huge market development there. and we can tie that into the waste systems already are existing in the city for carbon sequestration, so that it's not going into the environment, and we make a carbon negative energy that we can sell the carbon credits on. So this is our last slide, and it's just going to be in the background to maybe spark a few questions. So I don't know if that's, yeah?
Thanks for that presentation. Definitely a lot of interesting technical details to take in. From the cultural factor, you guys were looking a lot at Ireland's issues, Ireland's energy flows, inputs and outputs. But then, you'd mentioned that there's particular environments where some of the algae farms would be maybe more useful so as not to compete with agriculture like deserts. And so I'm wondering, in all your research, you spent a lot of time really getting to know Ireland, but how do you see this proposal and the sort of Irish energy matrix interacting with the rest of the world, right? You've gone between these two scales, but the second you start dealing with Ireland, you deal with the rest of the world as well. So how does Ireland sit in the rest of the world, and what did you guys learn about that from this research?
Well, in terms of how we're using our energy, it seems to be pretty similar. There are some notable exceptions. This product would be totally useless in Norway because they've just got so many waterfalls, they've got hydropower down, so we're not really going to be able to compete in that country. But we are going to be able to compete in countries like Austria, because they basically have a huge amount of peat that they can't extract because it's a huge amount of carbon emission. And it's actually got a high lipid density, and that's really what contributes to its emissions. So basically, if we can couple with them, then we can allow them to extract a huge energy reserve, and it's really cheap energy. They're not a big fan of the EU at the moment, but if we can couple with them, then we can provide cheap energy globally. Because that situation is replicated with Germany, for example. We know that they've got huge coal reserves that they can't use, and that's why they've become so dependent on Russian gas. You have a similar situation with China. They have huge coal reserves. They're growing a huge amount of fuel reactors there, peat and coal based, but that's not sustainable. Coupling that with the algae, we can grow there as well. So that is much more so on an industrial scale, though. In terms of the stove, the local energy saving, that's where we want to grow out of, because that allows us to trial a lot of these technologies,